Welcome, Geometry. So we're looking in our geometry book to lesson 64, and we are on page 424. And this week we're doing lesson 64 through 67. So the first concept we're looking on page 424 is angles interior to the circle. Interior meaning inside, right? All right. Now it says the measure of an angle formed by a tangent and a chord is equal to half the measure of the arc that subtends it. So remember that when we talked before about a tangent, we're actually looking on page 424. Remember, the tangent touches a circle one time on that outside. So I'm right in the middle of that page. So whatever angle I'm looking at there, if you find that major arc that it makes, take half of it, and that is the measure of the angle. So they're showing you there, measure of ABC is half of the arc BEC, and that's a very large arc. So that's why it's half of it. So remember how we talked long ago. If I have a circle, now I'm drawing it, so I know that you guys at home are saying, wow, that is a beautiful circle. That's exactly what you guys are thinking, right? So we're pretending that's a perfect circle. But remember, when it's a central angle, it's exactly whatever this arc is, this angle is the same when it's a central arc, right? Now, we've also learned that if it does this, then we've learned that this angle right here would be half of this arc, right? Because it touches one side to the other. Now today it's explaining to us that if I have a tangent, and that means it would just cross it at one point. We have to pretend there because my circle is really lumpy. So that's a tangent, it just crosses it once. So if I have an angle here, whatever this arc is, I take half of it, and that would be the angle. All right. So just some concepts to think about with a circle, especially if you're taking the ACT test. They're always going to give you enough information, so you have to kind of think through. I can still remember taking the ACT and thinking through, okay, they've given me enough information. What are some theorems? What are some postulates that I remember that's going to help me figure this out? And you just have those aha moments. Have y'all ever had that where you look at it and go, oh, that must be a right angle because maybe it was a semicircle that was intercepted there. So you know that it has to be half of it. So anyway, there's a lot of those that you will see on standardized testing. So it's important that you think through these concepts. Look on page 425. And it has a theorem for us there. It says the measure of an angle formed by two chords intersecting in a circle is equal to half the sum of the intersected arcs. So this is important to understand. So if I have a circle, all right, and you're pretending this is a beautiful circle again, right? And it says that there are two chords, meaning these chords do not have to go through the center. So mine are lopsided, but they're just, intersected. On the book, they have them way lopsided, way skewed to the right side, so it doesn't really matter. But it's showing you that the measure of angle 1 is AD plus BC. So those two arcs, AD plus BC, you add them together and take half. So if I'm looking for what this angle is, right? If I'm looking for what this is, then I would find out what this arc and the opposite, the vertical arc is, add them together and take half, right? So if I'm looking for this, I do the opposite. So that's what the book is showing you there. So you just add those two together, all right? And that's important. Remember that we talked before that these angles would be the same, but it's important that if we know these measures out here. So some of the facts that we know can help us solve other things. All right, look at example 3. How's this going to help me in some of the problems that I have? Good question. Page 425, example 3. It says find x. And these look just like problems I've seen on the ACT before. All right, so if I need to know what X is, I'm not sure if you all can hear that sound. That's actually my cat. I have a cat and a dog, and they fight like cats and dogs. So she is, that sound, did y'all hear that? That is my dog and cat, and they are chasing each other. But the growling one is actually my cat. So my dog wants to play, and my cat says, leave me alone. So anyway, she was standing right beside my computer. So I thought, they're going to think I'm really hungry because I could hear the growling. All right, let's go back to example 3. Even when we're on Zooms, we can get distracted, right? All right, so it says find X. Well, it gave me, I don't know what any other angle inside that circle is. So that's going to be difficult for me to solve it. But if I look, opposite of X is 70. And then the opposite arc from X is 195. So what do? I just add those together. 70 plus 195. And then I take half of that. So your book gave you the answer there. So it would be 265 divided by 2 would be 132.5 degrees is X. So that's just a neat way to solve those and to be able to figure out. Look at page 426, example 4, application tiling. Albert is laying tile in his kitchen in a circular pattern. So he knows that the measure of arc AB is 50, and he knows that the measure of CD is 86. He wants to know the measure of angle 1 so he can cut the tile accurately. Very important. Math is super important when you're doing renovations. I actually had a co-op dad come to me and ask about some renovation math. So it's super important. But aren't you thankful that you can go to Lowe's and all those little cutouts have been measured and laid, and you can just lay that down. So doing a circular tile at an angle, I can't imagine how tedious that would be. So hopefully it's a huge circle, right? So how would I figure out that angle? Well, we just learned. So the opposite arcs intercepted is 50 and 86. Add them together and divide by 2. So 1 would have to be 68 degrees. If 1 is 68, then also the opposite one is 68 as well. Because remember, those make vertical angles. Anytime we intersect, those opposite are vertical angles. All right, so that's all that you're doing in lesson 64. So practice A. And again, we're at the bottom of page 426. Find the measure of angle X in the figure. Let line M is tangent to the circle. Remember, tangent meaning it only crosses in one place. So I'll do my best to draw that. You guys at home can just keep in mind that I'm teaching you geometry and not art. And you can thank the Lord for that. All right, so the picture looks something like this. All right, so it crosses at one point, and it tells me that this whole area is 204 degrees. All right, so here is my circle, amazingly drawn, not so circly, but just pretend with me. All right, so how do I figure that out? Well, that whole arc is 204, so this angle would be half of that. So what is half of 204? X equals 102 degrees, 102 degrees. And that seems reasonable, because then this other one would have to be 78 degrees because it makes a straight line. A tangent is a straight line, and it would have to be 180 degrees. All right, look at letter B. Find the measure of MNO. MNO. Well, because that line is tangent, then I'm just going to double 92. So I'm going backwards on letter B. All right, letter C is a proof, and you're just using the theorems backwards that you know. All right, there are two cases you must prove. One is whether AB is a diameter, and then one AB is not a diameter. So you're doing that in letter C. All right, Letter D, find the measure of angle X. Well, remember on letter D, if I have two chords that intersect, it gave me this is 115, this is 59, and it wants to know what X is, right? All right, so I'm looking for what X is, so all I'm doing is adding these together. So 115 plus 59, and then divide it by 2 to get my X. So that's all I'm doing in letter D. All right, and then I'm going to let you do letter E on your own. It's an artist, a company logo. So that's actually a really neat logo. It's got a tangent and an R. How fun is that? All right, so I'll let you look forward to that when you do your practice this week. All right, let's look at lesson 65, distinguishing types of parallelograms. Now, one important fact to remember, parallelograms have opposite sides are parallel. So that's going to make some fun things because we know parallel lines, we understand they're equal distance apart from each other. Let's look at page 430. It says, if an angle in a parallelogram is a right angle, then the parallelogram is a rectangle. So that's important to remember that in a rectangle, opposite sides are parallel, but they're also, the opposite sides are congruent, and also all the angles are 90 degrees. So if one is 90 degrees, you know they're all going to have to be 90 degrees. How come? Because alternate interior angles are going to be the same. And so if one's 90, then they're all going to be 90. All right, properties of parallelograms. If consecutive sides of a parallel are congruent, then the parallelogram is a rhombus. Now, I know this is mind stretching because when you were a little kid, your teacher would hold up pictures and you would say square, rectangle. You would learn those terms, but it's hard for our mind to understand that every rectangle is also a parallelogram, right? But not every parallelogram is a rectangle. So it's kind of stretching your mind to think all four sides are quadrilaterals. Then you can get more specific with each quadrilateral. So that's super important to understand four-sided quadrilaterals and what their properties are. Remember that a rhombus, the properties of a rhombus, if the diagonals of a parallelogram are perpendicular, then it is a rhombus. So lesson 65 is just reiterating the properties that we know of particular shapes. So understanding what those are. Look on page 432, properties of parallelograms. If a diagonal in a parallelogram bisects the opposite angles, then it is a rhombus. So again, you've already learned these properties. It's just applying them. All right, is this parallelogram a rectangle? All right, and one important thing that you all need to learn is not just how it looks. You have to be able to do the math of that, because there's always this little caveat. Well, no, I can't say always, but a lot of times when you're taking standardized tests, they'll have a little caveat that says the picture may not always be drawn to scale. And that little line that they put on some of the problems really makes it difficult, because you want to look at it and say, well, it looks to me to be 90, but you can never assume in geometry that something is 90 degrees unless it is something you can use a theorem or a postulate or something they've given you. So you have to use a mathematical principle to prove that. All right. So lesson 65, practice A. Is this parallelogram a rectangle? Answer, yes, it is a rectangle. How do I know? Opposite sides are parallel. So checking the angles. The angles are, if I solve it, then I say 6x plus 12 equals 7x minus 1. When I solve it, x equals 13. So then I plug that in. 6 times 13 plus 12 is 90. And then 7 times 13 minus 1 is 90 as well. Since both of those angles are 90, the other ones have to be 90 as well. So is it a rectangle? Yes, it is. All right, letter B. Is this parallelogram a rhombus? Well, in order to be a rhombus, I'm going to solve, and let's see, it says 4x plus 7, 4x plus 7. If I set it equal, remember, in order to be a rhombus, all the sides would have to be congruent. So they told me one side is 81 over 5, so I can set 4x plus 7 equal to 81 over 5 and solve, but I don't get the same answer on the top and the bottom if I do that. So since the lengths are not equal to the side lengths, then it cannot be a rhombus. It would actually be a parallelogram. It looks close, but the top is it looks to me to be a little bit longer. But again, you can't just base it on what it looks like. All right, so that's what you're going to continue doing on lesson. That is the practice for lesson 65. All right, lesson 66, finding perimeters and areas of regular polygons. Don't forget that the term regular means that all sides and all angles are the same. So that's really important. If you look on the top of page 436, we don't typically do the warm-ups, but it says, which of the following polygons are regular polygons? Well, we know that C is a circle. Circles are never polygons because their edges have to be flat, right? Letter D, although opposite sides are congruent because all four sides are not the same, D is not regular. It is a rectangle, but it is not regular. It'd have to be a square to be a regular quadrilateral. The only regular polygon is A because all sides are congruent. All right, if all sides are congruent, all angles are congruent. So that is lesson 66. The warm-up number 3. All right, new concept. It's talking about the central angle of a polygon. How do I find those central angles? Then it says the perpendicular distance from the center of a regular polygon to a side is the apothem. We always have thought that's a funny word, apothem. Some of my students said it sounds like a possum when you hold your tongue straight. So anyway, it's a funny word. So hopefully you won't forget it now that I've made you think of it in a funny way. So how do I find the perimeter of a polygon? Well, in practice example 1, letter A, it says find the perimeter of that polygon. Well, if all the sides are 3, there are 6 sides, 6 times 3. The perimeter of that is simply how many sides times one side, and don't forget to put your label. So it would be 18 feet. Now, same for letter B. Now, how do I find the area of a regular polygon? Well, in example 2, it is 1, 2, 3, 4, 5, 6, 7, 8 sides. So it's an octagon. Oh, it says that. Find the area of a regular octagon with an apothem about 18 inches. So I know that in order to find the perimeter, it's just 8 times 15, right? Because there are 8 sides, each of them are 15. So the perimeter is super easy. The book said perimeter equals 120. I'm a little bit sad because they should have put 120 inches. We always put that label there, right, friends? Now, how do I find the area of that? Well, I take 1/2 times A, which I know that A, it says, and half the apothem length A, so that would be A is 18, it told us in the directions, and then I take the perimeter, and we've just solved that to be 120. So my area is 1,080 inches squared. Don't forget to put your labels on that. So they did in the apothem, in the area, but they did not in the perimeter. So make sure you put those labels. All right. So they've given you a few more examples there on how to solve it. So let's look at the practice very quickly. All right. Find the perimeter of this octagon. Again, octagon is 8-sided, so 8 times 32. And my label is yards. So that's all I'm doing for letter A. All right, letter B, use the area formula for for regular polygons to find the area of this pentagon. Pentagon is 5-sided. So remember what our formula is. I'm just taking the apothem, which the book told me is 13, and but I need to find the perimeter of it first. So 5 times 19, so I need to find that perimeter first. So on letter B, the perimeter would equal 19 times 5. All right, and so that's how I'm solving the perimeter of the pentagon. There are 5 sides. Then remember my formula for the area is 1/2 the apothem times the perimeter. So it's going to be area equals 1/2 times 13 times whatever 19 times 5 was. All right, I did not work that out, but I know y'all can plug that in your calculators, right? So that's all that you're doing on those simple formulas. So I think you'll do great on lesson 66. No problem, right? All right, so lesson 66. Now there is a little bit of a lab on page 443, and that covers regular polygons, and it's just starting about that and finding the midpoints and different things there, right? So that's a lab. There are some 5 questions with those. And again, any lab that you guys do, I do count those as bonus. It's certainly not required, okay? Now, lesson 67 is all about the introduction of transformations. Transformations just mean change. So anytime we talk about something being transformed, when I was younger, I used to love that TV show, Transformers. I used to watch it with my brother. So I can still remember the sound of that, Transformers. So it was just such a fun thing, but they would change like a car into a robot, right, or whatever. So that's what it means. The Bible says, be ye transformed by the renewing of your mind. That means to change, right? The world wants us to focus in on things that don't matter. But God said, lay not up for yourselves treasures on earth, but lay up for yourselves treasures in heaven. So we've got to transform our mind, right? I'm not put here on earth to get as many toys as I can. I'm put here on earth to glorify my Creator, right? My God. So that's really important. So your book talks about the different kinds of transformation. So you need to know these terms, and you're going to see these terms. So a slide is the simplest transformation. We call that a translation. It just shifts up, right, up, down, left, right. Those are just slides, and we call that a translation. So you do need to learn that and know the term for it. Now, a reflection, and you guys see, if you go to the mirror, you see a reflection, right? A reflection is just a flip. And you can do reflections on, like if you are reflecting on the x-axis, see how it flips, it mirrors itself. Or you can also do a reflection. I don't think I can do it that way. But anyway, not with my hands, right? But I could do a, like if I had a book, I can do a reflection top to bottom on the y-axis. So you can reflect it top to bottom, left to right. It can even ask you to reflect it around a horizontal or vertical line. They can say reflect it on x equals 2 and then reflect it that way. So a reflection is simply a flip. And then the last one that we're talking about is a turn or a rotation. And you kind of have to think of like the origin as a dial, and you're turning it, and it will give you the degrees. So there are some formulas to solve for those. So a rotation or a turn. So you need to know what each of those mean, and then how to solve that. All right, letter A. Identify the type of transformation. So what did it do? It just went up and left. So it went from the white to the shaded. So it went up and over. So we would just call that a translation. So that's it.
Marfield?
Yes.